Selanjutnya kita ada Eric Tan, seorang senior sales engineer dari Sysdig yang akan membicarakan tentang
Cloud Native Container Visibility and Security using the Sysdig Secure DevOps Platform. Tapi ada yang beda dari talknya Eric Tan karena beliau akan live langsung dari Singapura. Jadi kita akan video conference. Gitu. Round of applause untuk Eric Tan.
Covering ASEAN. My topic today is about cloud native visibility and security. Now, before I begin, I'd like to thank the organizers of DevOps Days and also our local partner, IT Group Indonesia. We have a booth at booth 9. Please come and visit us after this session. Right, let's start. Let's start with a bit of context and a background. I would like to share what we are hearing from our customers running production workloads in Kubernetes. When customers are initially starting with containers, their focus are around monitoring performance, availability, health and capacity, and also having the ability to troubleshoot issues quickly. But as they deploy business-critical applications and scale up their Kubernetes deployment, their cloud and DevOps teams are taking on responsibility for some of the security functions. Basically, our customers are seeing a convergence of security and monitoring into the DevOps workflow. The DevOps teams now need to answer questions like, how do I ship cloud applitions faster? And also, how do I deliver health and performance SLA? And at the same time, manage security risks and validate compliance. To answer these questions, what they need is a single source of truth across developers, DevOps, and security, allowing these different teams to collaborate more effectively. There's also a new challenge when using containers and Kubernetes. The challenge is that securing containers and Kubernetes is hard when you cannot see what's happening. There is now a lot of abstraction that doesn't exist before. You cannot see inside containers, and also traditional instrumentation methods do not work. At the same time, you need environmental context when using containers in orchestrated environments like Kubernetes. It's not enough to just say that I have a vulnerability, but you also need to know what vulnerability, where it exists, what services is it related to, and of course, how to fix it. As you understand, containers are ephemeral and transient in nature. They can be easily rehosted from one node to another node by the orchestrator. And when they die, you lose all records like logs and other debugging information. In this situation, doing troubleshooting, forensics, and incident response is going to be very, very difficult. Therefore, when you're scaling containers in production, it is easy to be left in the dark. Essentially, you cannot secure what you cannot see. Next, just a bit about Sysdig, who we are. Well, Sysdig's mission is to help you confidently run cloud-native workloads in production. We are founded by Loris Digiani, who is a and also we created and donated Falco, a runtime security detection engine to CNCF incubation stage, which means it becomes the de facto. So good momentum going. At this point in time, we have about more than 10 million Docker Hub pools of our images. When it comes to ecosystem integration, one.
Baik, nampaknya ada kesalahan teknis. Kita sambil menunggu sebentar.
And spending customers like Goldman Sachs, BNY Mellon, Standard Chartered, American
Okay.
Express, Visa, and so on. And our customer expansion mirrors their cloud adoption. As they go more deeply into containers, they're using more Sysdig. All right, let's talk a bit about the use cases that Sysdig address across the entire cloud native lifecycle. When we're talking about in the build phase, developers have to ensure they push vulnerability-free applications and are responsible for security image scanning early in the CI/CD pipeline. And of course, Sysdig helps them to detect vulnerabilities and misconfiguration using a single workflow. Now, once you start deploying your containers into any environment, and this is where we're talking about runtime security, okay, having the ability to report on vulnerabilities affecting running images in specific namespaces, clusters, and so on. And of course, Sysdig helps you to prevent and detect threats at runtime without impacting performance. Think of zero-day attacks and so on. End of day, okay, it's a basic requirement that Sysdig provides to monitor infrastructure and applications. Once an incident happens, okay, maybe an attack or something, we go into incident response. And this is where Sysdig will provide you with the deep insights to do forensics, to do audit, and of course, to do troubleshooting. And spanning across all three lifecycle, the build, run, and response phases, you must have the ability to do continuous compliance against regulatory compliance standards like PCI, NIST 800-190, CIS benchmarks, and so on. End of day, you want to have the confidence to run your containers in production. And the last slide, I'm not going to bore you with too many slides. This is the last one. Okay, I've talked about all these use cases. I talked about all these different capabilities that Sysdig provides. How do we achieve them? This is essentially done by installing a Sysdig agent. Our Sysdig agent is easy to set up, and we only need to deploy one single Sysdig agent to do both monitoring and security, a single source of truth. And our agent is deployed once per node, okay, either as a Docker container or a daemon set. And what we do is that after the agent is installed, we instrument the kernel by using kernel headers and also using ePBF. And by doing kernel instrumentation, okay, we are doing a non-blocking read of the system calls traversing the kernel. So we collect all information like processes, commands, file activities, networking, metrics like Prometheus and Sysdig, and of course, security incidents. So essentially, whatever you're doing inside containers on the host itself where Sysdig agent is running, okay, we collect the system calls. And this allows us to be the single source of truth, as system calls can never lie. Right, I'm going to stop my presentation and quickly switch over to my demo environment. Just give me a couple of seconds. Right, can you see my demo environment? All right, cool. That's very good. Thanks for confirmation. Okay, so what we have here is the Sysdig Secure UI, and we are now in the build phase. And what you're seeing now is a set of default, out-of-the-box image scanning policies. Okay, things like PCI, NIST 800-190, and Dockerfile best practices. So what I'm going to do is I'm going to drill into one of them, okay, NIST 800-190. Okay, and what we have here are a set of different rules. Rules to blacklist port 22. You shouldn't have port 22 running in your container. We're checking for Docker files where you embed, let's say a developer embeds AWS credentials or even passwords. And we're also checking whether you're running your Docker container as root within the container itself. Okay, so at the same time, you can also customize different gates that you want to do your image scanning against. Docker files, licenses, GPL version 2 and so on, not allowed. Secret scans, and so on. And of course, all these different policies, and you can also create your own custom policies, okay, can be basically tagged against image scanning for certain images. So what we have is that we do have a Jenkins plugin, and the Jenkins plugin, you can basically embed Sysdig secure image scanning as part of the Jenkins CI/CD pipeline. And after each scanning, it will generate a report here. Right, cool. So once your images are scanned and you start deploying them into any environment, you need to constantly evaluate them and monitor them. Just imagine last week you deploy your containers, okay? And just last night, one new vulnerability came out. How are you going to be informed? With Sysdig Secure, you can immediately be notified if your images was passing previously and now failed because of the new CVE. So what I've done is that I basically configured this into a different view to view from a Kubernetes standpoint, a namespace, a deployment, pod, and so on. Right? And here I filtered into just the Java app. Right? And you can see that in my Java namespace, I have all these different images, and I'm going to focus on Redis, which failed my image scanning. Okay, I'm going to basically drill into that. And while it's loading, you can see a summary of the different vulnerabilities, the different categories of vulnerabilities, severity level, and of course, the 3 image policies, the image scanning policies that it's been scanned against, and this gives you a summary here. And once it goes down into, let's say, we basically get data feeds, okay, CVE, security feeds from multiple sources. And we categorize them into operating system, non-operating system, and also at the application frameworks level, Java, Python, Node.js, and Ruby gems, and so on. Yes? Is there a question? Okay, no, I'm going to proceed. Right? So with this in place, right, okay, you get a breakdown of the different vulnerabilities, for example, at the operating system level. Okay, so in the interest of time, I preloaded one where, yes, it's good to have a list of the vulnerabilities which you pass on to your developers. Okay, so they fix it up. And then they release a new version of the image. Okay, take for example, this latest version of the image, Redis, is in February 27. But how do you know whether this new version introduces any new vulnerabilities? Okay, while fixing existing ones. And this is where Sysdig allows you to do a diff between the latest version and across another version. In this case, I'm choosing one that was in May and July last year. So here you can see a diff where this latest version introduces 3 new vulnerabilities, fixed 21 from the last version, but still have a pending of 41. Okay, so it's pretty important to know your risk posture whenever you deploy a new version. Okay, whether things are broken, have introduced new things, and so on. All right. After this is done, you deploy your images as containers into your cluster. You also need to ensure that your clusters are hardened. And this is where we use benchmarks like CIS Docker benchmarks and CIS Kubernetes benchmarks, which will then basically run scheduled tasks and scan your Kubernetes cluster. Right here we have Docker scanning. Okay, we have also masternode scanning for the Kubernetes masters. Okay, I'm not going to go too deep. If you're interested, come visit our booth. We'll do a deeper deep dive. Now, once your containers are ready, are clean, and your clusters are hardened, this is where we need to go into runtime security. You need to constantly protect your containers. And this is where Falco comes into play. Okay, out of the box, we have more than 30 different policies, which will cover a lot of different use cases to give you a very good default coverage of runtime security and detection. Okay, for this, of course, you can create your own custom ones, but I'm going to focus on a default one called terminal shell in container. Okay, a terminal shell container is an attack vector where an attacker is trying to open a shell container into your container. Okay, so this is very, very common, and it's usually one of the very first steps that the attacker will take. Again, we can scope it to any metadata that we gather. Okay, so we can scope it into any, let's say I want to scope it to a namespace. You can do that, Kubernetes namespace. So any custom metadata plus default metadata that we auto discover from the orchestrator, okay, we will pull it in and you can easily scope it to what you need. And of course, with this in place, you can of course use Falco rules. You can import from extensive libraries of open source Falco rules. Since we contributed open source, there are constantly new rules that's been added by open source contributors. Okay, rules from, let's say, to focus on FIM, file integrity monitoring, or even rules to focus on the MITRE and attack framework, which is a very extensive framework spanning 12 categories to give you different attack vectors. Right? You can import those Falco rules or create new ones yourself. Okay, once you have imported those rules, the next thing is that you can also take actions when this particular policy is violated, is triggered. you can kill or stop the container. At the same time, you can create a Sysdig capture. Okay, a Sysdig capture essentially is similar to a Wireshark PCAP file, but for a Sysdig capture, we are actually dumping a capture of all the system calls during a time frame. In this case, I've configured for 10 seconds before and 20 seconds after. And of course, part of any kind of enterprise system, you need to be notified. So we have notification channels, integration, and also webhook configuration. Okay, with this in place, okay, you can sometimes, it's also pretty difficult to know which Velcro rules to use for your environment. And this is where we can also do image profiling, where we do machine learning of your running containers. And this gives you confidence levels across areas like networking, process, file system, and also system file calls. And with this, let's say rules, you can then add this custom rules that we auto-discovered and add it to policies. And when it comes to pod security policies, if you're familiar with them, it's actually Kubernetes' own native ways of doing prevention. To prevent things from being deployed into a Kubernetes cluster, right? If it doesn't fit certain rules and regulations or compliance rules, which you can then factor into PSPs. Now, PSPs is very difficult to learn and use correctly, and that's why we allow you to use your deployment YAMLs to auto-generate PSPs, and then you can tune them and test them in our simulator, which then allows you to basically tune them to be not too permissive and not too restrictive, and then apply them. Okay, so this basically talks about runtime detection. Now, I'm going to run through a scenario, okay, using the terminal shell in container, where you're going to do forensics as part of incident response. So now that you have configured terminal shell and container and something triggered it, okay, now we go into the incident response phase where I want to understand what's happening. And as part of incident response phase, I need to know two things. Okay, I need to know what the objective of the attacker, what is the nature of the attack, what the attacker is trying to do. And I also need to know what the attacker is doing, what the attacker has done. Okay, so in this place, when this policy is triggered, I have the time when it was triggered, okay, the context, as I mentioned, you need to, it's not enough to know that an attack happened, an incident happened, you need to have the context. And here we have the context from Kubernetes, okay, the namespace, the deployment, the pod names, and so on, the host, the container, and of course, even the summary of what happened. And we also triggered a Sysdig capture, okay, which I'm going to dive a bit briefly. And also, I want to go next into the activity for this incident. Okay, what actually is the attacker trying to do? Okay, what has he done? So I can scope it to the time frame. I can look at different things, activities I've done. I want to look at commands now, the network things I've done, and also the kube exec. Okay, so here. Okay, so here you see the different commands that was created. Okay, let's say to focus on network, what has done from a network standpoint. He did a curl. I can now see the client and server port and IP. Okay, the scope, again, this is all context, the scope that you need to know to quickly troubleshoot and pinpoint, even the PID, the process name. From a command standpoint, every command that he executed, okay, there is a corresponding context that we give. The working directory where he did the tar and the untar, right? The commands, the PID, the PPID, UID that was used, and so on. And one more thing that Sysdig does uniquely, no other competitor can do that, is that we can, if let's say the attacker did a Kubernetes exec into the pod, we also capture the Kubernetes context. Again, context is important because that allows you to quickly pinpoint an issue and troubleshoot at the right area, reducing your mean time to recovery. So in this case, we capture the Kubernetes user group, username and group, additional resource context, okay, and also the scope which pod that it happened. And we can even go one step further by drilling down into the kube exec. Let's focus on, not the network call, but the commands. So now I have all the steps that was taken, okay, by the user. Okay, he bashed in. Okay, so I can see the sequence of attack, the sequence of commands. He bashed in. He did an LS to figure out where it is. And then he did a curl. He curled down a file called Villani. Okay, that's interesting. After which he did the base64 decode. Okay, after which he removed any existing previous installation, he untied, he unzip it, right? And eventually, okay, let me just reduce this filter, it's further down to just the commands. Okay, he extract the history. Okay, so I've already answered question 2. I know now what he did. Now I want to know all the files that's affected. I can see all the files affected. okay, all the files that was probably extracted from untarring and unzipping the downloaded file. Okay, so now I still have one question. What is his objective? What is he trying to achieve? And this is where, using the Sysdig capture, I can drill in. Remember, the Sysdig capture gives me all the system calls split into different categories. Okay, so in interest of time, I skip directly to analyzing the file contents that was downloaded. Maybe the file can give me some information what the attacker is trying to do. And I did find out, okay, through one of the files, he was downloading a new open source attack vector, and he was saying he was trying to install a rootkit. So essentially, he was trying to install a backdoor rootkit. So now I've answered the first question. Okay, the objective is trying to put in a backdoor. Right? So this essentially ends the workflow and what the Sysdig Secure offers. And oftentimes, okay, our users find that it's very more effective for them to do incident response and visibility, and to get visibility when they use both monitoring with security. And at the same time, our platform offers both, as I mentioned, okay, and typically, the first indication of a security attack, a security incident, is often a monitoring alert. And this is why they find our customers, our enterprise customers, find it very effective to use both modules together. Now, I'm going to run through a quick performance troubleshooting scenario, like a workflow, which is, I find, very, very effective to convey the value of the monitoring side. So what I'm going to do is that, just imagine last night, right in the middle of the night while you're still in deep sleep, suddenly you get a pager duty call. Okay, the voter app team just calls you and say that, hey, Eric, now I just found that my voting application, right, is running very slowly. And could you help me try to debug and troubleshoot it and figure out what's happening and give me some information? Now, before you can ask him more information, right, he just hang up. I think you can relate with that, right? So now you're left with a question. I don't even know much about the voting app. How am I going to basically troubleshoot it? And then you thought, yes, we recently installed Sysdig. All right, man, so let's use Sysdig. So now he told me voting app. Okay, having a perspective of hosts and containers is just not enough. And here I have an auto-generated topology map based on response time. So I'm going to switch. He told me that it's voting app. So he's using also Kubernetes. So let's switch to the deployment view. And I can see, okay, I have a voting app here. So let's click on this. Automatically, the view will be regenerated to focus on the voting app. And now, okay, so now I'm going to do a bit of discovery. I look at the voting app, okay, it contains, the voting app namespace contains 7 deployments. And since I'm looking at response time, you look at the lines here. Okay, a bolder line, a thicker line means that there is more time spent, okay, compared to relative to the rest. So I know that there's probably a bottleneck here. So I can now basically focus my attention onto the results deployment and the DB deployment. Let's dig a bit more. So I can see that this results deployment has 3 pods, okay, and that one of the pod is talking to the DB. Let's drill in a bit more. Right, it's using a Docker container. Okay, cool. Now it's talking to DB. Let's focus on the DB, and you can see that from a DB standpoint, okay, I'm not getting much information here. So the next thing, all right, I'm going to use another default dashboards to drill into, to get more information, to do more discovery. What I'm going to do is that I'm going to do a process dashboard, okay, a default overview by process. And you can see that this is still being filtered to the voting app. I can easily filter to any context that I want to, but now I'm totally focused on the voting app. And that's how easy Sysdig allows you to navigate and focus on the things that matter to you now. Right, I look at the CPU, memory, things still okay. Now, let's hover over the CPU percentage widget. I can now see all the different processes, okay, used in the voting app. It's using a voting app, okay, application, the custom application is using Postgres. So now I know that the DB is actually using Postgres, GUnicorn, Python, and is using Node.js, and so on. Right, so now I know that they're using Postgres. Now I want to dig in further. Okay, nothing looks out of the blue here in terms of memory usage, okay, but this is by process. So I'm going to dig in further. I'm going to use another default Postgres database dashboards. Okay, I'm going to go into this now. Now it's showing me the Postgres database performance and so on. Number of requests, about 9 requests per second, no errors. Average request time is 258, but max request time for max request time is topping out about 2 minutes, right? So if I look at this widget here, the default widget here, right, it's topping out average around 2 minutes too. All right, cool. So let's dig a bit deeper. Let's look at the requests. Okay, inserts is the most number of requests, and then the select queries are the slowest from the votes table. Now this shows me that the bottleneck is now more. I'm pretty more or less sure that it's dealing to the performance is actually being pinpointed to the Postgres itself, and specifically this particular select statement. But why is that? Can I provide additional information to the voting application team before I call them again and tell them the information? Okay, so let me look at container limits. Okay, since they're running as containers. Okay, as you're aware, container limits is essentially what you set to your containers, and as a best practices, you should be doing that to prevent runaway containers, right, taking up too much resources. Now, CPU shares is the request when it comes to Kubernetes, and CPU quota is the Kubernetes limit. Now, let's hover over this for a while. I can see that, 1,800%, 1,500%, 500%, and so on. So quite a few number of the application, the containers inside wasn't set with limits. Not a good thing, right? Cool, let's look at memory limits. Memory limits, pretty okay. Most of them are set, I think, with memory limits. Okay, it's still pretty okay from a memory standpoint. Okay, then let's look at the memory limit. Okay, all of them has been set with memory limit. Okay. Now, the database, the Postgres database is set with 256 megabytes as the max they can use. Now, looking at this widget, this is the most interesting one. Okay, CPU quota. Okay, only one container has been set with a CPU quota, a CPU limit, and that is the Postgres database. And the interesting thing is that this Postgres database is hitting the limit, which means it's using more than 200, it's trying to use more than the CPU limit that was set. Okay, which means that once that happens, right, you go into CPU throttling, and that can also be why, right, the Postgres database, the select statements are running so slowly because it was maxing out the CPU limit. Okay, so this effectively, I would say, goes through a monitoring workflow, a performance workflow, okay, and that basically ends my demo. Now, just to sum up, just to do a bit of summary, the Sysdig Secure DevOps platform is the only solution that provides cloud-native monitoring, security, audit compliance, and also forensics, a single one-stop shop, and we're the only solution can do that. Which means that you can use Sysdig Secure DevOps platform to consolidate up to 4 to 5 different tools. Okay? And we are built and designed from scratch to work with containers in the cloud-native space. Okay, so this ends my presentation, and I hope it has been informative. If you want to understand more, please visit us at booth 9. Again, thank you all for your time. Right, that's it. Do you have any more time? Sure.
All right. Thank you, Eric, for the presentation and for the sharing. Untuk teman-teman yang ada di main hall, Eric tadi pesan bahwa kalau ada pertanyaan tentang presentasinya, bisa langsung menuju booth dari Sysdig.